next problem is called letter case permutation, and it's a simple, you can say a simple backtracking problem. We're given a string S and we have to transform every letter individually to be lowercase or uppercase to create another string. We return a list of possible strings we could create and of all possible strings that we can create, and we return the output in any order. So we don't have to sort it, it's in any order it's acceptable. The constraints are that the string length is from 1 to 12, and the string consists of English letters, uppercase English letters, so lowercase and uppercase, and also digits. So in this example, we have A1, B2. So the first string that we can generate is basically just the same. We don't do anything. The second one is that we do the uppercase B. And the third one is we do the uppercase A. And then in the last, we do the uppercase for both the letters that we have inside the initial string. For the second example, there's only one letter, so the digits remain the same. We can either go with an option of having the lowercase Z or the uppercase X. So there are only two options. How do we actually generate all the permutations, all the combinations that we can have with the initial string? So basically, with the backtracking problems, we will always start from our base function, and we will have some helper function that we will be calling recursively over the input, the initial string or the array or whatever we have, and we will be gradually generating the output. And we will have a base case. So few things are important. Base case, in our case, the base case will be when we reach a string that we have generated that's of the same length as the initial string, because we know that we have transformed some of the letters, some of them we might not, and maybe in the last case we haven't touched any letters. So we just want to, for any strings that is an acceptable transformation of the initial string, we will have it that the base case is that we have the same length. Now the second thing that's important with backtracking is the decision-making process. So for decisions, we only have two decisions. So we can either do an uppercase or lowercase letter. For the digits, we basically just propagate down to the recursion tree because the digits cannot be transformed. So those are cases. Now we will go through the example, and also in the helper function, we always pass as parameter some important information. So for example, in this case, we will pass our initial word or the string that we are trying to generate another versions of. We will send the current index. The starting index will be 0. We will send value that we are generating right now. So in this case, it will be just an array of characters. And then we will send the result. We always send the result that we will, from the main function, return as the final output. And in the result, we will be just basically, once we hit the base case, we will be putting the current value that we generated inside the result. The word is basically just we always have to send the set of candidates, that we can use for the generation purposes. Now, if you go to our initial string, the root of we will just mark this imaginary root of the recursion tree. In the first, our first base case, when we call the helper function, we will have a letter A, so we can do the decision either to use the lowercase a or the uppercase a. And we are using the index 0 to fetch the first character in the initial string. So because it's A, we can do these two options, and we will increment the index 1 once we will do the first we will do the left recursion subtree. And in this case, we are now looking at the second character, which in our case is 1. So basically, next time when we call the helper function, we will have only one option. In this case, it will be 1. And we will then again increment our index to 2, so it's now pointing to B. While we are doing this, we are putting the characters that we have selected inside the current path of the recursion tree inside our array of characters. So we chose A, we chose 1, and then we have two options. We can either go with B, lowercase, or B, uppercase. Let's say we always traverse through the left tree, and we basically put B in the character array. Next, we will increase the index to 3, and we are pointing now to the last candidate, to the last letter in our initial word, which is 2, and we cannot transform it, so basically 2 will be this. Next time we call the helper function, the index will be 4. So that's our base case. The index is equal to the length of the word, and we don't have any more characters. So basically we have to put the current array of characters, we have to form a string and put it in our result. So the first string will be basically be A1, B2. We will do basically the same. When we are done with that, we will return from the from our last call of the recursion of the helper function. We will go to B, and because we don't have anything else here in the tree, we will go again back to here, and each time we'll basically discarding the elements that we have passed in the recursion tree. So we will discard 2, and we will discard B. Because we just covered them all. But next, when we hit number 1, we will go to the right subtree or the right node, and in this case, it will be the uppercase B. So in this case, and also because we are traversing through the recursion stack, the index will change. So it will reduce from 4, 3 to 2, and we will be again looking at the B candidate inside our initial word. And in this case, because we already had the left tree as lowercase b, in the right node we have the uppercase b. And we will basically do the same in the next iteration. So we will overwrite basically this b, and the 2 will remain the same. And this, when we will again hit the base case, and we will have to add the A1, but now uppercase B2. And basically we will do the same for A. We will go up the recursion tree when we are done with all the subtrees, and basically when we are done with the first left node, we will traverse then again through the right node, but now starting with the uppercase A. So we will get different versions of the initial string. And basically, when we are done with all of the options, we'll return to the main function. And so we'll be stop calling the helper function. And from the main function, we will just return the result. Because we are passing it by reference, it's okay just to return it as the result from our main function. Now, for the time and space complexity, we basically, for the space complexity, we only have this array of characters that we are passing through, and it's changing, and it's of the length. It's proportional to the size of to the length of the initial word. Now, for the time complexity, we will basically have how do we calculate it? We basically have two options. So our breadth, our width of the recursion tree, you can say, is 2. It's a maximum 2, and the depth of it is we go as far as the as we have candidates, and in our case, it will be the total number of candidates will be the length of the word. So in this case, it will be 4, and we can also put n because that's more generalized. And so we know basically that we'll be doing this n times. So the time complexity will be 2 to the n. Now, for every leaf node, we will do some computation. In this case, we are just copying over the array of characters to a string. We are transforming this array of characters to a string, which can be, well, depending on the programming language, it can be a linear operation that's linear in proportional to the size of the character array, which in our case is n. So we will have to add this additional multiplier n, or it can be constant. So in that case, we will have only 2 to the n. But because we will be using Java to solve this, it will be 2 to the nth times the multiplier n for the time complexity. We'll start by declaring first our result, which will be just a list of strings that we'll return after we have generated them. Then we will call our helper function, which we will define just in a moment. We will pass the initial index, which is 0, And for the current value that we are generating, it will be default value. It will be an array of characters of the same length as the input that we got. And the next parameter that we will send will be the actual set of candidates, which in our case is basically just the word that we have, the string that we have. So we will pass s as our third parameter. And for the last parameter, we'll just send the result, and we are sending by reference. So the things that we add inside the helper function will be visible inside the main function. So we can basically just return the result. Now to the main part of this problem. We will define the helper function. As we said, we are passing the index as the first parameter, and how we are traversing the recursion tree, this index will be changing. It will be incrementing or decrementing based on which direction we are going in the recursion tree. Current word will be our current generation that we are current word that we are trying to generate. The word will be set of the candidates. It will not change, and the list will be the list of strings that we will be injecting the words that we are generating. So first we will have our base case, and our base case is when we have an index that's of the same length as our set of candidates. We are out of the candidate, so we basically just can add the current string that we have formed inside the current word characters of array. To do this in Java, we will just call the new string constructor, and we will add it to the list of strings. Then we will basically just do the return, so we can stop the traversal through the recursion tree. So we are basically going back. Now, for the regular case, we will get the character at the current index, and you will basically check if the current character is digit. If it's digit, we know that we cannot do anything. We will propagate we will go to the next level of our recursion tree by calling our helper function recursively. But in a more interesting scenario where we have a character, we will have two options. We will first do a lowercase of the character, and we will call our helper function recursively. And then we will retrack. We will do the backtracking. We will overwrite the character at the, so in the previous scenario, it was this is basically a left node. It was a lowercase. Now in this case, it's a uppercase, and we are going back. We are still going down to the recursion tree by calling the helper function recursively.